So here we're starting. Like I say, I have the boards in there. That one there for SM12, and then 13, 14, 15, all wired in. You can see the jumpers are there for the ground. They're all wired up. I got the SMC12 card is also in. That's one of the ones I had to cut. So when you do that, if you notice, I soldered on this wire here to the ground bus in the back, and I soldered a wire on down here, which then goes up and over to 12 volts. Because once you cut a card, you lose the screw terminal connection. But that's all installed. All the LEDs are wired a lot more. There's a lot more turnouts in this particular cabinet, but they're all wired up, and the grounds are all run. The switches are in. I'll get those wired up. Those two are really tight there in the back, so I'm going to be careful how I solder those on. But that's the inside. Again, I'll get this all done as far as possible, and pretty much just be waiting to put the track in and the tortoises and run stuff back. There's only one switch, SM12, which actually is right up there. That's SM12. So I'll get that wired in. Obviously it doesn't go anywhere right now, but we will do that. And then in the back, as I sneak around here, bear with me, I don't have, as you can see, this is what it looks like before. This is what all the other ones look like as well. That's what it looks like before I put the board in with all the terminal boards for the turnouts. Again, the same thing. I originally brought my power in here, so I had to move it. So there's the 5 volt and the 12 volt. I ran the ground right in. This is a dedicated bus for the cabinet, so the ground wire fit. So I ran it right in. That'll be the feedback again to the S Mini when you get that done, similar to the other ones. There's 4 here, so I need an 8-point block. So I'll get this done. I'll get this all made up, get it installed, get it all wired. I got to run all these wires down, land them, and then you know, do all that shenanigans, and then pretty much then just be waiting for to get the turnouts installed and get them wired in. But it should be a lot quicker than not a lot of waiting. If I get all this done, it's just a matter of as soon as track gets in, turnouts are in, wire them up, and we're good to go. There is the, I haven't made it yet, but there's a layout for the back of Pittsfield. Across the top there, these will be the ones that are the mainline switches that are either dispatcher or hand controlled, and then the other 11 for all the turnouts that are in the transformer factory itself. They're just going to be straight control, manual control. So got to do all the drilling. It's a lot of work, drilling and everything to get that ready to go, mount it up, and then do all the wiring. Just want to highlight this. As you can tell, I'm not afraid to spend money. This is a tool that I was looking to get. This is actually a used, it's a crimper, so to speak, made for the insulation displacement connectors made by 3M. It's designed to work. It's got a 10-to-1 ratio. I got it on eBay for I think 26 bucks used. I mean, so it's not in the greatest condition, but it works. And man, it's a lot easier doing those crimps with this as opposed to a pair of pliers or lineman. I've tried everything, and I just never got good ones. So I decided to go ahead and spring for this. It works very, very well. Interestingly, it oops, sorry. You can see how the jaws operate, and they give you a nice vertical motion as opposed to a lot of pliers don't. It's kind of hard to see probably. I don't know, this will show a little bit better, but gives you a nice vertical motion, and it's designed. I used it for the connectors under here, back there, for those big mammoth jammas, which are number 12s. So there, you take some muscle to get those done. So something to think about. This is an EM, or what the part number is on this, E9-BM or something like that, but works very good, and highly recommend it if you're going to be doing a lot of suitcase content. I'm not sure I'd buy a new one, because like I said, a new one is about 70 bucks. Now if you're going to do a lot of them, I would recommend it because it's a lot easier. Again, you can pay me now or pay me later, but I saw this used and decided to pick it up. So highly recommend it. It works very well, and it's actually designed to, when it stops, that's actually the size of the IDC connector with everything ready to go, and close the hinge cover, and away you go. So I do recommend that. One more tool I found useful. This is especially for stripping the really tiny 24 gauge. Oh, it's not going to focus for me. On the multi-conductor, like the telephone cable. This works very well. The other strippers I had just didn't work. Was always breaking the wire. I had one of these, this one, and actually a smaller one that I had purchased. Actually, I purchased them at the MRI show out in Cleveland. Worked good for larger wire, but it just rips the crap out of the small gauge wire. So I bought this from Klein Tools. Again, I think I found it on eBay. So I kind of recommend it if you're going to be doing small stuff. And also, obviously, if you're doing DCC conversions, putting decoders in for stripping the smaller wire, it works very good. So just recommend that as well. Without it, I had a hard time stripping. Well, I could strip it fine, it always broke. Alright, one of the things I told you I wanted to show was, I think, perhaps a little more prototypical way to control switches, such as the one here for the Wallace pit track, which is going to be an electrically locked, not dispatcher controlled, but electrically locked, so the crew has to come in and basically unlock it. Right now, all we have is just your normal toggle on there, and that just, that's just a normal throw there, but there's no feedback to the computer or anything. The way we implemented it so far, this is the circuit. I think I've shown this before. This is the little circuit that gives you the LED. This does the feedback to the SMC12, which we've implemented like this, and we showed this already. So basically, when it's down, it's a motor, dispatcher controlled, goes to hand normal, the LED goes on, and you can throw the switch here. And it also will feedback that the switch is in hand mode. So to do something a little more prototypical, especially for one of these where it's not going to be dispatcher controlled, there's a circuit. Again, this is in the handbook, the CMR handbook, volume 1. This is the closest one that I came across, but it's not quite right. But this is basically hand or motor, and then you can throw it here, and that's the circuit, which is close. And they use a key switch here, so the crew has a key. You have to put the key in, take out a motor, and then you can throw the switch. That's not exactly what I want to do, because I want to say it's a locked switch, and you need a key to unlock it. So this little aluminum plate here that I got from ctcparts.com, you can see is an electrically locked hand-operated switch. So it's the padlock is inserted, I mean it's locked. If you unlock it, the LED goes on. If you desire to put one there, you probably will, and you can throw the switch. So what we're going to do is I found this switch. There's a lot of these key switches, but I needed one with some more contacts. So this is 4 contacts. 2 are normally open, 2 normally closed, based on the position of the switch. So what we're going to use this for is, if you look here at the circuit, Steve pans over, I'm not sure this shows up, but one of the switches that is normally, when it's locked, will be open, will have 12 volts. Another one will have 5 volts. And then this one, which is normally going to be grounded, shows that the turnout is locked. So the crew will come into the to do its work, get permission to unlock it, take a handy-dandy key, and they will, hopefully, they'll insert it in, and then they will unlock it. Well, when they do that, what that'll do is light the LED, because that'll move down, so then the LED will light, and then power goes to the toggle switch, which is your normal, typical tortoise double pole, double throw switch. Before that, when it's locked, there will be no power to the toggle, so you can sit there and toggle to your heart's content. It won't move that switch. So if you have no key, you have no switchy. So you have to come in, you have to put it in like that, unlock it. So that then again LED goes on, and now Steve's laughing. I made him laugh. Sorry about that. Little jiggles there on the camcorder. That'll power the switch. Do that, and then that'll open, which will feed back and say that. All right, pause it. All right, sorry about that. Steve had a hit of the giggles. So using and I have one spare switch, one spare set of contacts on this. So that I think is a little bit more prototypical. And again, we'll also feed back from the tortoise back to the computer that the actual position of the switch, whether it's normal or reverse. And the reason I'm doing that is because I guess in theory, what you could do is you could come in here, unlock it, do your work, leave the switch in reverse, go ahead and lock it, and then leave. Okay, so that's good. This will feed back that the switch is now locked again, but it's in reverse. The dispatcher needs to know that, so he can call the crew and say, hey, knuckleheads, you left the switch in reverse, so they can come back and fix that. Because I think otherwise that might be a problem. So that's what we're going to do. I bought these at All Electronics. I have 2 of them. We'll do one here for the pit track at Wallace, and one over there at the turnout for Lake City into the spur. Same thing. Probably take this and mount it somehow, out here on the fascia. I don't know if I want to go like that. It's hard to see, but we'll come up with something like that. And then this will be the actual. Again, this is the electrical diagram. One thing you always got to do is go to the physical diagram. So this is a mess. It's my first draw, but this will be the back of this. We'll have the key switch here, the toggle, the LED, using the same LEDs we've used already. A terminal board or wire stuff down, a resistor and everything, and then I'll bring everything into here. So this is the first draft of that, the actual physically how we're going to wire it. So I think it'll be kind of neat because again the crew will have to come by with an actual key and unlock it and then do their switching. So just wanted to give a little bit of update on that. And, as we get that done and installed, we'll see how it goes and see if it works the way I think it should. So that's it. So I think that's pretty much it for this update. So thank you very much. So that's it. That's the update for now. Like I say, want to finish all the controls, get them all pretty much done, waiting for turnouts. The next big push will be, as you can see, we got all kinds of stuff around, but we don't have any tracks, so I need to get the turnouts made and start laying them in, and then like I said, it'd be pretty easy to get them in, get them installed, and the switches for them on the control cabinets are ready to go. Get all the track done here in the yard and in the engine terminal, so we can actually keep things stored up here on the layout. And then after that, might actually start some scenery once we get everything done. And then move in here to the factory, get some of this European equipment here put away, and move ahead and get the factory started after that. So more to come. We'll keep working diligently here. And again, thanks for watching. Do appreciate it. And stay tuned for more updates.